Hello and welcome back. In section 3.2, we look at derivatives of exponential and logarithmic functions. So we'll start with the derivative of e to the x. So I'm going to have you try out, just using your calculator, finding the limit as h goes to 0 of e to the h minus 1 not in the exponent, just a separate term, over h. So h goes to 0, so small values of h. Go ahead and pause the video and see what limit you come up with. Welcome back. Hopefully you saw that this limit is 1. That's going to come in handy in a moment. So we're going to let f of x equal e to the x. And f of x plus h is e to the x plus h, which we can also think of as e to the x times e to the h. Multiply with the same base. Shortcut is add those exponents up. So then, by our limit definition of the derivative, f prime of x is the limit as h goes to 0 of f of x plus h, so e to the x, e to the h, minus f of x. F of x is just e to the x, all divided by h. So we have a common factor here of e to the x. E to the x is a factor that doesn't have an h involved in it, so we can actually even pull it in front of the limit. So f prime of x is then the limit as h goes to 0 of, we have e to the x up front, e to the h minus 1 all over h. And there's where your little experiment comes in. That part is worth 1. 1 times e to the x is e to the x. So the exponential function is its own derivative. The derivative of e to the x is e to the x. Since again, this part here is worth just a 1. So let me have you all try to differentiate. G of x is, let's see, we'll do 15 e to the x plus 7x cubed minus 4x squared minus 2 billion. So see if you can find g prime of x. Okay, welcome back. So g prime of x, hang on to the factor, derivative of e to the x is e to the x. Hang on to the 7, 3 becomes a factor, x cubed gets knocked down to x squared. Hang on to the factor, negative 4, 2 is now a factor, x squared is down to x to the first, and the derivative of any constant is always a 0. No matter how big or small that number. So g prime of x, just a little cleanup here, 15e to the x plus 21x squared minus 8x would be our derivative. So for our next property, we're going to consider f of x to be the natural log of x. And f of x plus h is natural log of the quantity x plus h. And there's not really much to do as far as simplifying that. Then our derivative, f prime of x, is the limit as h goes to 0 of f of x plus h, so natural log of the quantity x plus h, minus f of x, so natural log of x, all divided by h. Now here, notice we have the difference of logs that have the same base. If they have the same base, and they do, these are both base e, we can write that difference as a single log of a quotient. So we can call f prime of x the limit as h goes to 0 of the natural log of x plus h all over x. And then we have an h in the denominator separately. So the next thing we're going to do is something we're always allowed to do in math. We're always allowed to multiply by 1. So the same thing that let you build up 7/11ths into, say, 14 22nds way back when you were learning to add and subtract fractions, we can use here as well. So this time the multiplying by 1 that we're going to do, though, is going to be of the form x over x. And as long as x is non-zero, which it does have to be because of the restriction on the domain of logarithms, this is just then worth a 1. And what I'm going to do is pull just the x from the denominator. So f prime of x is going to be 1 over x times the limit as h goes to 0 of, so then this x at the top is still here, so is the x at the bottom. And as long as we're making things look a little bit different, the same thing that allows you to add, say, 1/7 and 2/7 and get to 3/7 in your head is that we add or subtract the numerators and keep the common denominator. Remember, we're always allowed to work backwards as well. We're allowed to split it up, and that's what we're going to do. We're going to split this up. So x over x plus h over x. So f prime of x, 1 over x times the limit as h goes to 0. We'll hang on to this x over h for a minute. X over x is 1, so we have 1 plus h over x. And I lost my natural log. My apologies. Natural log. My natural log disappeared there. Natural log of 1 plus h over x. Now we can turn factors in a logarithm problem into exponents. That's the next thing we'll do. F prime of x is then 1 over x times the limit as h goes to 0 of the natural log of 1 plus h over x to the x over h. And here's where we're going to do a little bit of substitution. I'm going to let u equal x over h. So if h is going to 0, u is going to infinity. You get a denominator that's getting smaller and smaller. The result is getting bigger and bigger in absolute value. So our u is approaching infinity. So a little bit of substitution. I'll have to do a little sliding back and forth on here. F prime of x. I'm going to hang on to the 1 over x that we had at the bottom of the previous page. Limit as, instead of h is going to 0, u is going to infinity. We still have a natural log. We still have a 1 plus. Oh, here's where h over x, that's the reciprocal of x over h, so that is 1 over u. and we're raised to the x over h power, we're raised to the u power. This should look familiar. Limit as something goes to infinity, 1 plus 1 over that something to the something. This is worth natural log of e. And the natural log of e, as we saw before, is just worth a plain 1. So we have 1 over x times 1, or 1 over x. So the derivative, recall that at the start of this, f of x was natural log of x. F prime of x is 1 over x. So let me have you all try a couple from the book. Y equals 10 x cubed minus 100 natural log of x. And see if you can also differentiate y as natural log of x to the 5th plus e to the x minus natural log of e squared. So again, on both of these, we're going to find y prime or dy dx, whichever you'd like to call it at the moment. Okay, welcome back. So our first one, we didn't need any changes in the original format. I'll hang on to the 10, multiply it by that 3 that was an exponent that's now a factor, hang on to the x, drop the 3 to a 2, hang on to the coefficient of 100, and derivative of natural log of x is 1 over x. And then we just do a little cleanup. So 30x squared minus 100 over x. Our second one, we do have to do a little bit of work first. So I'm going to stay in y equals form. I'm not differentiating yet. The other one, I didn't have to do any manipulation. I could dive right into the derivative. We're not differentiating yet. We have exponents inside of these logarithms. We'll turn them into factors before we differentiate. So 5 natural log x plus e to the x minus 2 natural log of e. And natural log of e, hopefully, is starting to ring a bell. Natural log of e is just 1, so 2 natural log of e is just 2. Now we're ready to find dy dx, or y prime. So 5 times 1 over x. Derivative of e to the x is e to the x, and derivative of any constant is 0. So y prime here will be 5 over x plus e to the x power. So the next one I'll have you try. We're going to look at the limit as h goes to 0 of e to the, we'll start with a 5, e to the 5h minus 1 all over h. And then try limit h goes to 0 of e to the, let's say, I don't know, 11h minus 1 all over h. Okay, so hopefully you found that the first limit was a 5, the second limit was an 11, and in general, the limit as h goes to 0 of e to the ch minus 1 over h is going to give us, in general, the c, whatever constant. So why is that useful for us? For our next one, we're going to look at f of x equals e to the cx. Well, then f of x plus h, It's e to the c by x plus h. And we can do a little bit of separating there. So that's e to the cx plus ch. So f of x plus h, e to the cx, e to the ch. So if you're multiplying with the same base, your shortcut is add those exponents, and that works either to put them together or to separate them out. So f prime of x is going to be the limit as h goes to 0 of f of x plus h, e to the cx, e to the ch, minus f of x, e to the cx, all divided by h. So f prime of x then is, we can pull a common factor of e to the cx times the limit as h goes to 0 of, what's left in the first term would be e to the ch. Second term is just a 1, still an h in the denominator. And by the property that we investigated just by, we didn't necessarily prove it, but just investigated with small values in the calculator, we saw that this is worth c. So then f prime of x is e to the cx times c, or ce to the cx. So then the next thing we look at is, okay, well, what if we have different bases? So we'll start with y equals b to the x. Well, then I can take the natural log of both sides. Natural log of y equals natural log of b to the x. So natural log of y is x natural log of b, just properties of logarithms. If I translate this logarithmic back into an exponential, I now have a base e. So I can say my base e raised to the power on the other side, x natural log of b, is worth y. So this is just translating from exponential to logarithmic. Well, natural log of b is just a constant. So this really is following the rules from the previous page. So then if y is e to the natural log of b times x, and I'm throwing this in parentheses just to emphasize x is not part of the argument of this natural log. X is a separate factor from this constant that is natural log of b. So the derivative of this is just following that c e to the cx pattern. So then y prime is, our constant is natural log of b times e to the natural log of b times x. So that's our derivative when we have b to the x. If we have a log with a different base, we just use the change of base stuff you used back in your college algebra days. So if we have y equals log base b of x, we can turn that into natural log of x over natural log of b. Natural log of b, again, is just a constant, so this is of the form constant times natural log of x. So for our derivative, we hang on to that constant and differentiate natural log of x. So then y prime is 1 over natural log of b times 1 over x. So the idea on both of them is just we do the work to make the base look like base E, what we had before. So then we can put that to work. Let's see, so we'll do let's see, find the equation of the tangent line, TL, remember tangent line of f of x equals natural log of x to the 6 at x equals 4. Let's see, so that's the first one I'm going to have you do. Then I'll have you try g of x is equal to the log of x to the 7th plus 5 to the x. So give those two a spin, pause the video, see what you can do with them. Okay, so problem 1. Let me just copy that onto a new fresh page here. F of x is natural log of x to the 6th. Yeah, x equals 4. All right, so we're not ready to differentiate yet. So hopefully your first step, you held on to that f of x. So f of x is now equal to 6 times the natural log of x. So f prime of x is then 6 times 1 over x, or 6 over x. So to write the equation of a line, we need a point and a slope. So to find the point, I would find f of 4. So that is the natural log of 4 to the 6, which is 6 natural log of 4. To find the slope, I would find f prime of 4, which would be 6 over 4, which is 3/2. So then change in y is the slope times change in x. So our y value, 6 natural log 4. Our slope, fraction form 3 over 2, and our x value was given as a 4. So y is 3/2 of x. 3/2 of 4, half of 4 is 2, 2 by 3 is 6, and then plus 6 natural log of 4. This has a natural log, this does not. This is as far as I would go as far as writing my equation. So then in problem number 2, start a fresh page here. We're told that g of x was the log of x to the 7th plus 5 to the x. So hang on to our g of x. That exponent is going to become a coefficient. So 7 log of x, 5 to the x. Let u equal 5 to the x. Take the natural log of both sides. Natural log of u is natural log of 5 to the x. The x now becomes a factor. And then translate it back into exponential. So e to the other side, x natural log of 5 is worth u. And that's also our 5 to the x. So this is e to the x natural log of 5. we're closer to where we want to be, but we don't have the base e on the logarithm yet. So we'll have to use the change of base. Recall that if they don't write a base down for us, that is assumed to be base 10. So this would be 7 natural log of x over natural log of 10. Hang on to the rest of it, e to the x natural log of 5, natural log of 5 being a constant. Now we're ready to differentiate. So g prime of x, I hang on to the constant part, 7 over natural log of 10, and differentiate natural log of x, which is 1 over x. Same thing on the next one. I hang on to my constant, natural log of 5, and multiply by e to the cx again. So on that one, there's not too terribly much cleanup that we can do. So that would be 7 over x natural log of 10. And I either put the constant in parentheses or throw the variable at the front of the line to emphasize that the variable x is not part of the argument of the log. Similar here, what I ended up doing was using the parenthesis method. So then plus natural log of 5 by e to the x natural log of 5. So that would be our derivative of g of x. Okay, so this was section 3.2. I would recommend 1 through 20. I'm sorry, 1 through 12 all, and then 13 to 57 on the odds. And if you have any questions, please feel free to get in touch. Stay safe out there.